When you think of the word mechanism, you'd probably also think pivots, hinges, and gears. Most of the machines we see today are made from a lot of rigid moving parts. For something essential like a light switch, you expect them to last decades or even a lifetime. My family moved into our new house back in 2013, and only 7 years later, our light switches have already begun to fail. There are some inherent flaws with traditional mechanisms. They tend to have a lot of moving parts, which lead to more things that can break. Friction is also a common issue. If you have two parts rubbing against each other, you often need lubrication to keep them running. Otherwise, they break down. Or worse. Yeah, that. Introducing the compliant mechanism, a system that performs useful work by flexing. They're not as weird as you think. Everyone has used one at some point, possibly in the form of a plastic lid, a mouse button, or anything with a spring, really. Even your heart is a naturally compliant mechanism. The humble bow and arrow, one of the oldest tools ever made, is literally a bendy stick with a piece of string. Compliant mechanisms have plenty of advantages. Three of the most important ones are lower cost, reduced part count, and higher performance. A traditional light switch looks rather simple from the outside, but when you take it apart, you can see that it is anything but simple. Aside from the rocker itself, this thing has a whole bunch of components stuffed inside of it. Compare this to a compliant switch mechanism, which was amazingly built from just one part with no assembly required. This makes it much more durable on top of being easier and cheaper to manufacture, while also performing better by eliminating friction altogether. Using a 3D printer, you can make a compliant tool like a set of pliers using a single piece of material at a fraction of the price to buy a rigid tool. Having fewer parts, no friction, and no wear and tear means they can last for a very long time. They're not perfect though. Designing these mechanisms can take longer and can be more complicated since they have limited motion, unlike a pin joint that can freely rotate. You also need to be careful about choosing the right material, since the parts that bend also need to be thoroughly stress tested to ensure that they can handle repeated use. Despite this, compliant mechanisms have diverse applications that can solve real-world problems, other than needing better light switches, of course. Hospitals can work with 3D printing companies to mass-produce disposable surgical tools, like forceps, at a lower cost than their rigid counterparts. They are usually made from stainless steel, which is more expensive and harder to dispose of. Since they use hinges, there are gaps between the parts that are more difficult to sterilize than compliant tools. When our healthcare system is under extreme stress in these challenging times, making medical tools more affordable has never been more important than now. That being said, 3D printing today is still mainly on a small scale, being a relatively new technology, but there is a lot of potential for mass production in the near future, and compliant mechanism research is a fast-growing area of study. Now, I'm not saying everything should be made out of bendy parts, but there is much to learn and much to gain from understanding more about compliant mechanisms. So to all the engineers out there, especially the ones who are designing light switches, I challenge you to think outside the box, and also to be more flexible. Thanks for watching.